Welcome, Algebra 2. Today we're going to go over Chapter 10, Day 10, which is going to discuss probability of compound events. We have some warm-up problems to get started, so let's begin on those. All right. So for the first one, we have the median is 51 in this data set with 4 values. We want to find the value of x. So the median is the middle number, so that would be the number that's right in between those two values. All right, how we find the number that's right in the middle of those two values is we add those values up, divide by how many values we have. All right, so that's x plus 42 divided by 2, and that gives us 51. Now to solve, we would multiply by 2 on both sides to get rid of that division. So we get x plus 42 equals 102, and then subtract 42, and we get x equals 60. All right, that's the very mathy way of finding the answer, but obviously we have another way. All right, if 51's right in the middle, then it's an equal distance from 42 and x. So 42 is 9 units away from 51, so that means x is 9 units away from 51, so that means x is 60. All right, in the next example, the mean is 10. How we find the mean is we add up all these data values, and that's including the one that we're looking for, and divide by how many data values we have. We have 7 values, so that means if we did 5 plus 7 plus 9 plus 10 plus 12 plus 14 plus x, that value we're looking for, we would get 10. All right, it's important not to forget that x. All right, if we divide that sum by 7, we would get 10. So now let's just work backwards. So let's multiply by 7. All right, we would get 70. All right, and 70 equals that sum, which would just be 57 plus x. If we add up these data values that we can. All right, now just subtract 57, and we get 13. So that's how we could find a missing value if we knew the mean. In example 3, Claire conducted a survey of students in her classes to observe the distribution of eye color. The table shows the results of her survey. So we want to find the probability of each color, or rather, if she selected one random person from this survey, what's the probability that their eyes would be blue? All right, really simply, okay, we figure out how many people had blue eyes. That was 16 out of the total amount of people that were surveyed. So to get the total, we just add them up. We get 94. All right, so that'd be 16 out of the 94 have blue eyes, and that would give 0.17 or 17%. Okay, the probability that a randomly selected person from the survey has brown eyes would be the amount of people with brown eyes divided by the total, so that's 64 over 94, which would be 0.681 or 68.1%. In other words, 68.1% of the population that was surveyed has brown eyes. All right, for green eyes, we got 4, so that's 4 out of 94, which would be 0.04 or 4%. And then finally, for hazel eyes, that's 10 out of our 94, to be 0.106 or 10.6%. All right, so let's get into the meat of the lesson, which is going over probability of compound events. All right, so we're going to find probabilities of what's called unions and intersections of events. And we'll talk about what that means in just a second. Your homework is the Chapter 10, Day 10 worksheet. And like always, if you have any questions, you can email me. All right, so the union of two events is all the outcomes that are either an A or B. Now what we have to take into consideration is some events are what are called overlapping events, and then other events are called disjoint events. Okay, overlapping events means A and B can happen at the same time. Okay, disjoint events means events A and B cannot happen at the same time. So examples of that. If we go back to our flipping a coin example that we did in the past, when we flip a coin, we're either going to get heads or we're going to get tails. Okay, so those would be disjoint events. We can't get both at the same time. And I know some of you are saying, wait, what happens if it lands on its side? Well, we just reflip. Okay, that wasn't an outcome. All right, we didn't get anything there. Okay, for overlapping events, there's events in which A and B can occur at the same time. Okay, so an example of that might be, drawing a card from a deck. All right, if event A is drawing a club and event B is drawing a king, okay, both of those events can happen at the same time. There's a card that's the king, the king of clubs. All right, so that would be an example of an overlapping event. So the intersection of A and B is all the outcomes shared by both A and B. All right, so what we're going to have to figure out is, are the events overlapping or are the events disjoint? Okay, the union or intersection of two events is called a compound event. All right, and that example would be in the middle there. Okay, so for overlapping events, we're saying that those two events have outcomes that are in common, meaning they can just happen at the same time. Event A and event B can happen at the same time on one trial in an experiment. So we've got this equation from last time. That was for overlapping events that we dealt with the spinner. So the probability of A or B occurring is just the probability of A plus the probability of B minus the probability of A and B occurring. The probability of A and B occurring is just how many times they both occur. Okay. For overlapping events, the probability of A and B is not going to be 0. Okay, if the probability of A and B were to be 0, then they wouldn't be overlapping. All right, so we're going to use this for overlapping events. And for disjoint events, we're simply just going to add them up. All right, disjoint events just means those events are mutually exclusive, which means they both can't happen at the same time. And if they both can't happen at the same time, the probability of A and B is 0. That just means they can't both happen at the same time. All right, so we simply just add up those probabilities. So let's take a look at example 1. All right, first we want to tell whether events A and B are disjoint or overlapping. This is going to be the most important part of every problem. All right, because we have to decide whether the disjoint or overlapping in order to find the probability of A or B occurring. So in part A, notice that the probability of A and B is 0. All right, so that means these two things cannot happen at the same time, which makes them disjoint. So if they're disjoint, I'm just going to rewrite this equation one time here. If they're disjoint, the probability of A or B occurring is just the probability of A plus the probability of B. So that would just be 0.2 plus 0.4 or 0.6. So 60% chance that A or B occurs. Now in part B, notice that the probability of A and B is 0.05. All right, so that tells us there's some events where both of those things can happen at the same time. So if both of those things can happen at the same time, then we have overlapping events. All right, so if they're overlapping events, that means the probability of A or B occurring is just the probability of A plus the probability of B minus the probability of A and B, which is the outcomes that they both have in common. All right, since they can happen at the same time, they have outcomes that are in common there. All right, so now let's just plug in what we have. The probability of A is 0.35. Probability of B is 0.10. And then the probability of A and B is 0.05. Okay, so if we do this, 0.35 plus 0.1, 0.45, 0.45 minus 0.05 is 0.4. So the probability of A or B is 40%. All right, so like I said, the most important thing to decide first is whether these events are disjoint or whether they're overlapping. Okay, in this example, take a look at the diagram that we have. Notice that these two circles are not overlapping. There's no events that are in common between those two events. All right, so in this case, that means these events are disjoint because event A cannot happen at the same time as event B. All right, when we draw one card from the deck, we can't get both a 10 and a face card. All right, it's not going to happen. All right, the only way that happens in a standard deck of 52 cards is if we drew 2 cards. All right, and that's not what we're trying to figure out. So the probability that the card is a 10 or a face card is just the probability it's a 10 plus the probability it's a face card. Pretty simple. All right, so we've got 4 outcomes in which we could get a 10 out of those 52, out of the 52 cards. If we take a look at B, we've got 12 outcomes in which we could get a face card. Remember, there's Jack, Queen, King in the deck of cards, and we've got those 3 for every suit: clubs, diamonds, spades, and hearts. All right, if we add those together, we get 16 out of 52. Now let's just simplify. So 16 out of 52 is going to be 4/13, which would be 0.307 or 30.7%. All right, I'm going around to the nearest thousandth. Okay, in these examples, I wouldn't take points off on a quiz or a test if you rounded to the nearest hundredth. All right, this is just my personal preference. All right, if you take a look at example 3, a 6-sided die is rolled. All right, what's the probability that the number rolled is less than 3 or greater than 5? So first, let's just think about the outcomes that we can get on a normal 6-sided die. All right, that would be 1 through 6. We want to figure out the probability that it's less than 3, or greater than 5. We got to figure out if these events are disjoint or overlapping. Now, the amount of outcomes in which we could get something that's less than 3 would be 2. The amount of outcomes that we could get something that's greater than 6 would be 1. Notice those things aren't overlapping. We can't get something that's less than 3 and greater than 5. So that means this is just going to be the probability that it's less than 3 plus the probability that it's greater than 5. All right, so that means probability that it's less than 3 is those 2 out of the 6 outcomes. The probability that it's greater than 5 is that 1 out of 6. So that's 3/6, 1/2, 0.5, or 50%. All right, we got 3 left. All right, in example 4, once again, we're going back to these card examples. We're selecting one card out of the deck at random, and we're going to try to figure out the probability that the card is a face card or a spade. Like we said before, we got to figure out, is it disjoint or overlapping? Clearly from the diagram, we can see that this is overlapping. They have events that overlap, meaning they have events in which both of them could happen at the same time. Okay, if we take a look at these 3 cards, all right, they are both face cards and spades. All right, so that means since they're overlapping, let's just write out our equation. Once we get accustomed to these types of problems, maybe you won't need to write this equation anymore. But the probability that it's a face card or a spade, or there we go, is the probability that it's a face card plus the probability that it's a spade minus the probability that it's a face card and a spade, because that's possible. All right, so the probability that it's a face card would be the amount of face cards we have out of the total amount of cards. The probability that it's a spade would be the amount of spades, which is 13 in every suit, out of 52 cards. And then obviously, like we talked about before, there's 3 outcomes in which we could get something that's both a face card and a spade, which means we double counted those events. All right, so we have to subtract the amount of times we double counted those events. All right, so we have 12 plus 13 minus 3. Okay, so that'd be 22 out of 52, which is 11/26. If we type that into the calculator, we get 423 to the nearest thousandth, which is 42.3%. All right, and that makes sense. If we take a look at the amount of cards here, if we just add them all up, we get 22. All right, it's really easy when there's a diagram. We could just count them up, and that's simple. We wouldn't double count it. Okay, we're not going to go back over and double count those 3 events. All right, but we have to be aware of situations in which we don't have a diagram, so that we know intuitively if it's overlapping that we double counted events there. All right, so a good example would be the next one. All right, this is kind of confusing wording here. In a class of 20 seniors, 17 have applied to a state university, and 11 have applied to a private university. In all, 19 of the 20 students have applied to a university. Okay, what is the probability that a class member chosen at random has applied to a state university and a private university? What we're trying to figure out is how many people have done both. So that would be those people that lie in the middle there. All right, so we're saying that these are overlapping events. Okay, but it's not readily apparent, okay, how many people lie in that region with just the information given. All right, so let's just use our equation. We know it's overlapping. Okay, so let's say the probability of A or B is the probability of A plus the probability of B minus the probability of both A and B, because we know that there's some that are overlapping there. All right, so if we just plug in what we know from the problem, it says 17 have applied to a state university, period. Okay, that's the people that are in this region. All right, that's including those people that have done both. All right, so that's 17 out of the 20. And then it says 11 have applied to a private university. All right, so that's these folks. And it says 19 of the 20 students have applied to university. That's everybody. What we got to do is solve for this part, the probability of A and B. All right, so this is just a simple algebra example. Okay, there's a lot of things that we could do to make this a little bit simpler. We can simplify like terms here. If we do that, we'd get 28 out of 20, which obviously would not make sense. Okay, that would be saying like 28 out of the 20 applied for university. That just doesn't make sense here. And we know it's 19 out of the 20. All right, so we're going to subtract 28 twentieths, and then we would get, let me erase this so you don't think that's a negative. When we subtract 28 twentieths, we get negative 9 twentieths equals negative times the probability of A and B. All right, so if we want to get the probability of A and B, we just divide by -1, and we get 9 twentieths. There's some steps that I'm going to skip in the future. That's going to be one of them. This is kind of an unnecessary step. If we just find the difference between the 28 and the 19, we're going to figure out the number of people that apply to both a state and private university. All right, final one. Very similar to the last one. With 25 students, 13 have a dog and 8 have a cat. In all, 16 of the 25 have a dog or a cat. What is the probability that any one of the 25 has a dog and a cat? A cat. And this one, it's pretty straightforward. So it has words like or and, which makes it really easy to figure out what's the probability that any one of the 25 has a dog and a cat. We can just write the equation. We know it's overlapping. And just as a side note, even if it wasn't overlapping, this would still work. So this equation would still work even if it's not overlapping, which almost makes it, makes the case for, well, why don't we just use the equation all the time? Okay, because if this is 0, -0 doesn't do anything, so it would still work. All right, but there are events in which people have both a dog and a cat. That's what we're trying to figure out. All right, so just from the problem, let's fill this stuff in. 16 of the 25 have a dog or a cat. 13 have a dog. 8 have a cat. All right, and then we're just figuring out the probability that they have a dog and a cat. All right, so we can just add these up. We get 21. All right, and the difference between these two, 16 and 21, is 5. So that just means the probability, like I said before, I'm skipping some steps here. All right, the probability that one of them has a dog and a cat is 5 out of 25. All right, if we want, we can simplify that. That's 1/5, 0.2, or 20%. All right, folks, that's it. Once again, if you have any questions, please email me. And have a good day. Bye.